Hey, this is Dr. B, and this is our second investigation of the atom. We just talked about some basic facts initially. Now let's talk about some properties, but not of matter, but of waves. As things get really small, matter and energy seem to collide, and this happens when you get it down to about the size of an electron. So if we're going to study an atom, we really need to know about electrons, and electrons have wave-like properties. It's been observed some time ago that if you pass light, which is a form of energy, through two slits, you can get interference patterns on the back, a clear indication that light is traveling in waves just like it would as a liquid here. And if you have a wave, you must have a wavelength. That would be the length of the wave in meters, and it can be for light. It can go up to the radio waves, which can be hundreds of meters long. The amplitude would be this height here, half the height of the wave. Frequency would be how often it passes a fixed point, a matter of seconds for liquid waves, but perhaps a matter of nanoseconds or even less for light, since it's traveling at 300 million meters per second. For all electromagnetic radiation, we can express this as a relationship between wavelength and frequency. It's inverse. As the wavelength gets longer, the frequency becomes more infrequently, becomes shorter, less frequent. And therefore, we have this inverse relationship, and we can use it to solve some problems. For example, what is the frequency of green light that you may see at a traffic light? Well, we can convert these nanometers into meters because we are going to have to cancel with our meters here. So we can simply call this 522 times 10 to the minus 9th meters. I would rearrange this equation to solve for frequency, and I would plug in. There it is right there. You can do estimates here. Notice that this is 8 minus a minus 9th, so we're in a very, very high frequency regardless of this wavelength, and we end up with somewhere in the realm of 10 to the 14th hertz. These are some properties of waves.